In computing, there's a lot of ways to do things, but there aren't that many ways to do them correctly. So I think there's a slide before that. Yeah. Okay. So So we'll start there. Yeah. So as I say, I studied maths, and then I quickly switched to computing. And when I finished that, I went to Imperial College, and I studied what was then very new and was called artificial intelligence. So I'm talking a long time ago, I won't say when, but it was in the last century. And artificial intelligence had already been discovered in 1956 and was being rediscovered in the 70s and 80s. Now artificial intelligence has been born again. And each time it gets reborn, it's reclassified and it's focusing on very different things. So it's a kind of, one of the things I say about computing is really like a fashion industry. A lot of the things are the same, but the names change. So a lot of the things we learnt and we were doing, my professor said, oh, we did that in Fortran, but we called it call by reference. But then we were doing it in Pascal, and then someone else did it in C++. Programming languages haven't really changed conceptually. They're mainly based on the Van Neumann destructive assignment, flawed architecture, which will probably never go away in our lifetimes. But the idioms and the connotations and the semantics and the names change. So, but what happened? Oh, it's moved.
It was on a timer.
So if we just go back. So yeah, so I've lectured mainly about what I know about computing to people all over the world, mainly in Malaysia, and I've presented at conferences. Yeah. I ended up, when I left Imperial College, I ended up at LPA, which is a very small company up the road. And we had a couple of dozen people at one time, but now we're down to a dozen. And we've been working in AI and working with various companies in the UK and overseas for a number of years. So LPA was brought up on this weird language called Prolog, which stands for Programming in Logic, which was popular probably in the 70s and 80s and even into the 90s. As with a lot of symbolic computing, it became rapidly unfashionable thereafter, as did the terms AI. So when we set up another company in 2000 called Business Integrity, we were told not to mention AI at any cost. We were told to take it out of all our merchandise and collateral, because at that time people were only interested in, say, maybe object-oriented programming or whatever it was at the time. So as computing evolves, the terms change, the fashion changes. We haven't changed doing what we do. We're doing what used to be called and is still called knowledge-based systems, expert systems. Some of you maybe did come across this at some stage. I think it used to be an option at LSBU, but it's probably one of those options that comes and goes as the perception of the marketplace changes. And it's quite strange because, you know, it would have not really been conceivable 5-10 years ago to think that AI was now flavour of the month, and it is. But it's not the symbolic computing AI, it's more obviously the GPT AI, which is taking over so fast that people really have no idea what to do with it, other than students who evidently are using it to write their lectures.
Do you feel that things like ChatGPT are like going to be the forefront of it? Obviously, you said like the forefront of AI with like adoption, right? But do you think this has been a long time coming already? Because I went to a lot of lectures and like things like CodeX, you know, that conference in King's Cross, and they was talking about like the future of AI. And general artificial intelligence. How far do you feel we're away from that as well?
But that's like a philosophical discussion, which
Okay.
really I have no interest in.
Okay, you're more on the physical side.
On the practical side.
Practical,
I mean,
yeah.
you know, trying to build computers that in some way resemble human beings to me seems pointless and irrelevant. And cognitive modelling is something that I've never paid any attention to. But I understand some people are fascinated by it. But I think that I don't like what I see, but what I see is incredibly impressive.
Yeah.
I've read some articles written by the AI engine that
Yeah.
are passable.
Yeah.
You know, they are definitely a bit boring, but no worse than a lot of the articles that are written. And I can see students using it in, maybe not in computer science, but to submit work. And I think lecturers would be very hard pressed to spot it.
Because I heard ChatGPT got like a MBA or something.
It didn't get a very high score. It wasn't top of the class, but it was passed.
Yeah.
It was passed. It can pass.
Yeah.
It doesn't mean it understands anything. It doesn't mean it knows what it's doing. It has no semantic understanding. But by digesting 4 billion websites and regurgitating them, it's got incredible results. And the legal industry, which is the one I'm mainly involved with now, is fascinated by it. And all the big law firms are looking for graduates who can help them work out what to do with it. So, I mean, you know, obviously, it's probably not part of the syllabus here because it's only now becoming the thing. But if I was you and you're interested in computing, and you're not just here to get a piece of paper and go drinking every night, if you're serious about computing, then you should definitely go and get to grips with GPT AI in your own time. You don't need lectures, you don't need courses. It's there, you can go help yourself, it's free, and you can see what it can do. My son sent me a rap. He likes rap.
Yeah.
He sent me a rap about some footballer. I said, that's pretty good. How long did it take you to write? I said, I didn't write it. He said, GPT AI wrote it. I just told it what style to.
Yeah.
And it's frightening that it's.
Do you feel like that much access to information for like an AI chatbot, like, does it have to be regulated, or like, would it be like? I know it's open source right now, but like,
It's worrying for sure. It's worrying because, you know, it's very unclear what will happen if it's unregulated. That's for sure. So there's a lot of questions ethically and morally, but I'm not interested in them.
Yeah.
I'm only interested in how I can fit my ideas of symbolic reasoning with this phenomenon, which it is. And that's what the meetings I'm having are about, how we can combine, in effect, machine learning with what we used to call AI.
Yeah.
So old AI and new AI, without getting caught up in the philosophical discussion of cognitive modelling and consciousness and all that stuff.
Yeah. But
It's
I
like,
think we're far away from that.
we are far away. AI is basically probably somewhere around, people would say, someone said the other day, it's about the age of a 3-year-old.
Yeah.
I would say no way, I would say it's more like 6-month-old.
Yeah.
You know, it's miles and miles away from human beings. Human beings are incredibly, maybe not everyone, but most are very, 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 very intelligent.
Yeah.
And able to multitask and think on multiple levels at the same time. You know, the computer is impressive though, because you know, the computer can beat me at chess.
Yeah, that's what I was
and I'm a
thinking.
decent chess player. The computer can beat my colleague at chess, and he's a phenomenal chess player who can beat 20 human beings simultaneously.
Yeah.
You know, the computer can beat Gary Kasparov at chess.
But do you think like comparing like a machine's cognitive capability to like a human's cognitive capability is like a bit like it's got like its flaws, because like you can't really compare a human that, I mean, personally, because I'm a believer in like the spirit and the soul and like the mind as well. But like I don't want to get too philosophical on that. But it's like how can you compare a robot to a human basically?
Well, I would agree. There's no merit in that line of reasoning really. But what you can do is judge the output of the robot with the output of the human. And now the output of the robot is starting to catch up with the output of the human in certain situations. And if we look at generative text, which is where most of the money is going at the moment, you know, I've even used the robot to generate text, low level collateral about topics that I can't be bothered to write about in detail. I can just throw it to the robot and it will generate me a couple of pages.
So I'm not gonna let you go. I'll let you do your
Sorry
about that. I'm sorry.
No. I think it's very interesting because it raises ethical, morals, practical issues about computing, specifically GPT AI, but computing in general.
Do you feel so? Just one last thing. Sorry, like because like you know like they say consciousness, like we don't know about our own consciousness. I was speaking to this with like my brother, but he's not like really technical. He's not a very technical person. He's more like a spiritual person. But like he was talking to me about consciousness. He's like, oh, do we really have like cognitive consciousness, or is it just awareness of like our surroundings? And it interested me because it was like, if a computer, like, do we scale a computer level of awareness of like own self as well, of like the sense of like knowing that it's being here, like sense of, obviously it's like, is that like the scale that we would?
I would, you know, when I first got involved with AI, there were a lot of philosophers and psychologists and people from the arts in the room. And there was people like me who came from a mathematical background. And I really couldn't talk anything with them, and they had lengthy discussions about the things you're raising. And as a scientist, I failed to see what the point was. I have become aware that there are some interesting discussions that could be had. But what does it matter? I mean, are you going to say that you want to try and build a computer along those lines? No, you're not, because the digital engine works totally different. But what you might be aware is that there is a thing called reasoning, and then there's a thing called meta-level reasoning, which is what we do. So we have
metaphysical.
Well, I wouldn't go metaphysical. Meta-level reasoning is reasoning about reasoning. So reasoning about reasoning is you may know there are certain rules to do with how these objects can be used. But a meta-level reasoning strategy would be one that tells you which rule to apply first. Because there are many rules that you could apply. The order in which you apply the rules determines the behaviour. So if you pick the cheapest rule first, you will get one behaviour. If you pick the most expensive rule first, you'll get another behaviour. Whatever cheap and expensive means. But when you have multiple options, there is a decision making about the options, and then there could be decision making about that decision making. So there are layers of reasoning, and we can replicate them in the computer if we want to by building models along those lines. But it's unclear, and what machine learning has showed that is you don't really need a lot of that stuff. You can just almost with brute force do a lot. So a few years ago, Dave Ferrucci was at IBM, and IBM had a team doing some research into AI. And Dave Ferrucci said, we're all researching these different things. And I've been working with him on Brutus, which was a storytelling machine generator, so it could generate stories, templates. And he took his team and said, no, what we're going to do, we're going to build a solution that can beat the world-leading players at a game called Jeopardy, which in America is very popular. So they spent 3 years and they built this solver. And the way Jeopardy works is Jeopardy is a game show in America where they give you the answer and you have to work out what the question was.
Yeah.
And it's actually very complicated. It's all back to front logic. So he and his team built a digital version that could play this game, and they took on the world champions of Jeopardy and beat them. And that was called Watson. And IBM released Watson, and they gave him a team of 1,000 people, and they said this is now a $4 billion industry. And they told him to stop working, and they sent him all the way around the world to talk about Watson. He was so pissed off, he left, and he went to work in Connecticut for a hedge fund. And now he's got his own company. But he set up Watson not to model human reasoning, just to win a game show. He said, there's no semantic interpretation there, there's no consciousness, subconsciousness, I don't care about any of those arguments. All I'm doing is I'm getting all the answers I can in the world chained together to go backwards into a disentangled query. So I take a query, I disentangle it, disambiguate it. That's all a bit complicated. He used Prolog to do that. Then he said, right, and then I've got 57 blade servers running in parallel. Brute force will get me an answer quicker than a human. So, IBM then launched Watson and said it's going to cure cancer, which it clearly was never designed to do. And GPT-AI is not designed to do anything other than generate loads of text, or in the legal law firm business, to try and digest historical contracts and work out what the hell we signed up for. So there's a lot of companies out there, tons and tons of contracts sitting in cellars, and they've got all sorts of liabilities, indemnities, warranties outstanding, and they don't know what they are.
What of like these systems? Sorry, I don't want to like keep you.
No.
But what of these systems are flawed, isn't it? Like these flawed systems. Like, so say for instance, like you have like a legal documentation, and then they miss something, or like a. It's very hard for AI to miss something within like a legal documentation, but like, what if like something's missed within the contract and then there's like a loophole, but the AI don't get the lingo of the.
Well, that's exactly what's happening.
Yeah.
The most recent article, which I think it only came out last week, that was saying that the robot was asked to generate a non-disclosure agreement, standard non-disclosure agreement, but which was weighted heavily in favour of the vendor rather than the seller. And it couldn't do that. It could generate a standard NDA, but it couldn't understand the subtlety in terms of the limit of indemnification, which is a big thing in computing. So if I'm selling my software to you, you want indemnification in case my software is flawed, right? And if you're going to use it to power a vehicle, and the vehicle crashes, and the crash is due to my software malfunctioning, and the crash knocks down an old lady, and there's a $10 million lawsuit, you want that $10 million off me. But you only paid me $500 for the software. So I want to limit my indemnification to you to the $500 you paid me. And that's where a lot of the nuancing goes on. Well, the robot couldn't understand how to finesse that, and even with prompting, it came back with a form of words that basically limited the indemnification wrongly. So I mean, but for first draft, it was pretty impressive. It had 48 sort of sections, and each section was pretty robust. But it was only when you really get into the subtleties, an experienced legal person would say, no, that's not how we want to play it. But, it's interesting. Computing is moving forwards, but it's not perfect, and programs are only as good as their perceived behaviour. And humans are flawed, and computers are flawed. I mean, computers are similar to humans, they just make different mistakes. and they make the same mistake all the time, whereas humans are making mistakes on a random basis, based on, you know, how they feel that day. It affects. So different results can be obtained at different times from the same person, or certainly from different people in the same company. So it's a lot more random. Computers are consistent in that if the algorithm's wrong, at least the answer will be wrong probably all the time. So you should be able to track it.
Yeah.
But you know, we've sort of covered all the slides now almost. I mean, the thing is, no, that's okay. I don't mind. The interesting thing is with software is that with a lot of the projects I've been involved with, the fun is early on creating the thing, and we have a small team of people. It's exciting, and we've got ideas, and we're talking to the business users, and they're going, "Wow, look at that!" And we're doing all this amazing stuff, and then we have to make it work properly. And it's like, oh God, everyone's lost interest. So we have to get another team of guys in, and they have to knock it into shape and make sure it works every day, every minute of every hour of every day. And that's a different mindset. And interestingly enough, on most of the projects, we end up with a core team of 3, 4, 5 computer scientists, and then we have a few testers. And as the project goes on, the development team stays the same or maybe even reduces, and the amount of testers, you can't fit them in a room. And I always say to people that I know, if they're interested in computing and they are happy to work with repetitive, boring, detailed work, then go into software testing, because that's the bottleneck. Because if the software isn't tested to a certain level of acceptance, it can't be deployed.
Yeah, that's more
because it's not provably correct.
Is it more so around unit testing, so that testing for bugs and like testing
all sorts of testing, unit testing, module testing, acceptance testing, integration testing. There's so many types of testing. There's armies of testers out there.
Would you say AI could replace that job? In the sense of like testing software, in the sense of, cause I know like there's certain like degrees of like computer scientists like I went to a speak at UCL and they were talking about.
But would you trust it?
Yeah.
That's the thing. I mean, could AI do it? Maybe, but would you trust it? How would you know?
Yeah, but what if the AI makes the code itself and then it generates like the test as well? Like, say
well, you wouldn't trust it to make the code and test it. That makes no sense.
I know.
That's like asking you to write me a program and then ask you to test it, because your flawed vision in writing it will be the same flawed vision in testing it.
Okay. Because even like with like, say like commercial products, like say for instance like social media, like for instance, because I'm like building a company myself right now, so that I'm building a decentralized social media and blockchain, but it's like I've looked at different like things like conversion, like marketing tactics, like conversion for users. So basically, how much users convert into like monetary assets or like monetary gain, and like. I'm not that in it for the money, but I'm in it for like the user experience as well. And it's like, do you like look at the system with the sense of like the business like values and like the integrity of the business, or do you look at it like within the sense of like how good is the technology? If you get what I mean, or am I going too off or?
I have no idea what you're asking me.
So no, basically, so like I'm building a system, I'm building a decentralized system that's gamified, but then it's like, how do I like convert? How do I like find a way to kind of like get people to test it and like get like people to basically market? I know it's like marketing.
All I would say is the hardest thing in computing is monetization. The easy thing is building software. That's easy. Anyone could do it. I'm sure anyone in this room could do it. With all due respect, it's not difficult. You know. The harder thing is coming up with the understanding of what to build. That's hard, because it's easy to build stuff that no one cares about.
Yeah.
I've seen a million projects where people have built wonderful things and no one cares.
Yeah.
The hard thing is to understand what the market might want when your software is ready in a year or two.
Yeah.
So, you know, and understanding how you might disrupt the market and fit in the market. And within that, there is the whole idea of monetization.
Yeah.
And the best solution there is to go out and read Crossing the Chasm by Jeffrey Moore.
Okay.
And it should be compulsory reading in every computer science course, because it is the Bible for high-tech businesses, and it explains how to go about in product placement, product positioning, and how you can build a market presence. And you know, it's not easy how to monetize software, however brilliant it is, however well engineered it is. And I will just say also with Contract Express, which we probably can go to the next slide maybe. I created Contract Express around 1996, was the first instinct of it, and we set up a company in 1999, and we raised, I think, $100,000 to market it. It was to generate legal contracts for lawyers based on contract templates with placeholders, like mail merge on steroids, but with an AI theme that did rule-based inferencing, blah, 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 blah. We ended up borrowing $1 million by the time we got the thing out there. It cost $1 million, not because the software didn't work, but because we didn't look right, we didn't have a sales team, we hadn't tested it enough, we hadn't gone through security checks enough. It cost $1 million before we actually could sell it. And you know, in 2015 we sold the whole thing to Thomson Reuters for a lot of money. You know, but it took 13 years to make any money, and it took a lot of money to get into a stage where we could monetize it properly.
But do you think that's easier now because it's simple access to funds?
No, I don't think it's easy at all. I think it's very, very difficult. I think it's very, very difficult. I think you got to be incredibly gifted to understand the dynamics of the market and the market opportunity and how to penetrate it. You know, you're up against huge players. You're up against huge players with bucket loads of money. And it's hard. I think writing software, you know, with all due respect, I've met a lot of very good programmers and great. And I was one once. It wasn't that good, but I was okay. It's like, so what, you know? It's like the same in music. You know? Before I got into computing, I was a bit of a musician. And one day I was playing music, and I suddenly realized I was in a room with a load of people who could all play as good as, if not better than me. And I thought, well, this is pointless because there's no business here. You know, no one's going to get signed up in this room in a hurry. But at least with computing, you've got transferable skills. You'll always be in employment. There'll always, as long as you're presentable, as long as you know how to talk, and as long as you know how to listen. And it's the listening thing that's essential. You have to be able to listen and absorb and translate. Because what people tell you they want and what they want are two totally different things.
That's interesting.
It is interesting. It's very interesting. But the programming, that's great that you know Python, Java, whatever. That's all good, you know. Technology is good, especially if you're interested in it, you know. I was never really that interested in it, but you know, it was easier than maths. And I was interested in maths, but it was hard, you know. But the people skills, that's the bit that really is essential. You need to learn to listen and try and empathise with what people are saying, to understand and anticipate what they want. So when you're writing your code, you're not writing it specifically as they have asked you. You're writing it in a way that allows you to enhance it, because you know that probably round the corner they're going to want that box to be not blue but yellow and blue, maybe with some stripes. So when you're writing your initial slice of code, you've already abstracted out some of these parameters. So later on, if they turn around and say, oh no, I want the blue to be green and I want the stripes in, you say, no problem. I've got a facility to provide that.
So is that more so like consultancy work, or like doing like freelancing work, or like companies, or like for?
Well, it could be in any context. I just wanted to check the time, because that clock is not right.
No, it's 3
3
o'clock.
o'clock.
2 minutes to 3.
And I don't want to, I mean, I don't mind rambling on. I can ramble on forever.
You can have a discussion after if you want.
No, because I've got to go to another
Okay, cool.
thing. But I mean, if anyone else is, I mean, they're not interested in the back. I don't know why they're here. You're in the wrong room. This is a computer.
Sorry, I giggled at what?
No, not you. The people behind you seem to be. Oh, you are here. Okay. Has anyone got a question? Otherwise, the two of us would carry on.
So I
don't mind. It's interesting. Okay, so let's look at another slide. We'll cover it. So another project I was heavily involved with is Inflow. You can Google this guy about his creds. He's a world leader on social network analysis. These diagrams here are this is typically what he does. He looks at a group of people and how they're clustered around certain topics and how those clusters interoperate. And what he found is the big one he was telling me about was he went into an organisation that had hundreds of people, and they had the official sort of marketing, sales, product development, product support, all the different departments. And then he goes in with he's a social anthropologist, he's a social scientist, he goes in with his soft survey which says, who do you talk to, who do you look to for inspiration, who do you respond to, who do you know socially? And he captures all these metrics, and he found out that within this organisational hierarchy there were little pockets of people who were tightly knit and other people who were outliers, who were out the loop and have no interaction. And then within these little pockets of people that spend a lot of time doing stuff together and are well integrated, you will find there's maybe one person here who connects this group to this group, and one person here connects to this group and this group. These people become key influencers. So the influencer paradigm is kind of based around this, that if you can grab those people's attention, you can access multiple pockets, multiple clusters. And similarly, if you block them, you can break these things apart. So he went into this was in the era of what was called downsizing. He was asked to go in, and they were going to, I think it was IBM who were his client, they were doing a consultancy, and they were in effect going to say this guy, this guy, this guy, and this guy. And he showed them, well, if you get rid of those 4 people, yeah, you'll save some money, but these cohesive units will break apart because you will have taken away the people on what's called the shortest path. So the shortest path is measurable, and you can measure everyone's distance from everyone else. And this is based on, I don't know if you've heard it, the 6 degrees of freedom. Everyone knows Kevin Bacon. You know this one? No? Everyone knows Kevin. Okay. You can Google it. Everyone knows Kevin Bacon by the 6 degrees of freedom. Basically, everyone knows, let's say 1,000 people, so 1,000 people times 1,000, that's 1,000,000 times 1,000, 1,000 million times 1,000. After 6 steps, you've covered the planet. So everyone knows everyone else kind of thing on the planet after 6 steps of separation. Okay, so this social network analysis is a mathematical treatment of a social science, and this was very interesting, and he's applied it in a lot of areas, and we helped him write the software, and he's used it in his business, and he monetizes it actually not by selling the software but by selling his consultancy. So that is something. What else we got? What is innovation? It's disruptive, productivity enhancing, democratization. You can open up technology, you can open up decision making. The stuff that I tend to do is to do with making decision modeling systems transparent, consistent, they're fast, and there is a role maybe in empowering people to do things that they can't hitherto do. So say like we have spent time putting some immigration law on the computer with a lawyer who used to charge $500 to each person who wanted to know whether he or she was eligible for a certain visa. By putting it in an expert system, the lawyer could potentially make that freely available to people. So there is social good that can come out of computing, social good that can come out of computer programs that enable people to access resources that they hitherto couldn't easily access. It could be doctors, it could be medical advice, it could be all sorts of things. Whether it's using GPT AI or not, I don't know. But innovation and information technology are able to hopefully make the world a better place. If that's of any interest to you, and with some people it's not, which is fine.
Do you feel like with like the current standard of like with like the war in Ukraine, and sorry to go into this, but it's kind of a weird one, but like do you feel like with the war in Ukraine, is it gonna like affect the way like the world's gonna be run in the future as well? We're like in the sense of like the race on AI with like China and America right now as well. Because I was at Parliament actually, to be fair, and I went to an AI defense. It was like an AI. What was it again? It was talk about defense with AI, and they're basically talking about like how you can use AI for defense systems and like military systems. I don't know why I was there, but like, it was like.
Well, I don't know either. You know more about it than me because I wasn't there. I had no idea. I imagine so.
Yeah.
I imagine the Russians and the Chinese are busy developing their own robots and algorithms.
But do you think this is like dangerous for like the growth of AI? Say for instance, like
it's always been dangerous. We had it in the 70s with Ronald Reagan and Star Wars. We had exactly the same discussion.
Okay.
That Ronald Reagan was going to put this set of interlinked satellites in space that could shoot down nukes. And a load of academics wrote petitions saying this is the beginning of the end and blah blah blah. You know, there's this constant tension between letting the machine become very intelligent and controlling and making decisions and humans, you know, and it is a constant challenge.
I know they talk about like the singularity theory where they think like
but these are for people that want to talk about stuff like that.
I hear that. More time I believe that it's like fairy talk, but at the same time I get the logic behind it, but at the same time it's like more creative because it can't like logically it can happen, but logically it can't happen. But like,
you know, there are people that talk about things that are not easily provable or disprovable. I don't subscribe to that personally. So you know, you can spend a lot of time conceptualizing what consciousness may or may not be. But to me, it's not necessarily something I'm interested in because I'll never know. You might as well talk to me about heaven and hell. You know, I'll never know. So that's. Yeah, but different people are interested in different things. So if it's your thing, fine. But you know, there are people. I've met a few people who have similar interests and concerns, and you know, I'm not one of them. So just pressing on. You know, in theory, information technology can help relieve people from slow, tedious manual tasks and free them to do interesting things. I often think when we go into places, people kind of look at us and say things like, "Oh, we're all going to be made redundant." And I say, "Well, hopefully not. Hopefully not." And you know, normally it's not the case. Sometimes it is, obviously, but normally organisations value their staff and say, no, by automating certain parts of their task load, they can now concentrate on the really difficult stuff that needs their attention. But obviously it's not guaranteed. But it's nice to think that information technology can be used to improve processes and take away some of the slow manual stuff that ties people up and slows everyone down. And what's your role? I mean, your role when you leave here and you go out there with whatever language, Python or whatever's on your CV, you know, Java, C# or whatever it is, you know, if you're going to want to sell yourself to an employer, I would say the main thing is to improve your communication skills, where, you know, because I know from when I've looked at potential hiring, people have come in with incredibly impressive sort of CVs, and then you think, yeah, but are they going to fit in? You know, are they socially adept? Will they integrate? Could you ever imagine putting them in front of a customer? Also, I had people come in claiming they'd written wonderful programs, and what we would normally do is give them a little thing to write, leave them in for 30 minutes, and come back and see if they could actually. And a lot of the time they couldn't. So you know, there was a lot of doubt about what people had put on their CVs and reality. So a CV is just there to get you an interview, and the interview is all about your personality.
So you have to use something like HackerRank or like a leak code to like sharpen up your skills on like different like interview questions, because that's what I do more time as well. But like, have you heard of HackerRank?
No. But as I said, I'm not a great believer that people are looking to appoint people who are technically brilliant. I think most of the time they're just looking to appoint people who are rounded and will be good team players and can be customer facing. So,
so basically, you're basically describing like a salesperson, basically.
Yeah.
But like, is that the future of like the way like developers are going to be like?
Well, I think it's not the future. I think it's the present. I mean, most
of like AI systems, like most.
No, nothing to do with AI. I think it's the way the computer industry has been for a while. Most of the technicians, the pure technicians, are locked in the back room and no one lets them out, and everyone else is out there.
It's basically like Wizard of Oz, right? Where you got the wizard. He's controlling the system, but he's pretending to be like this amazing wizard or like this amazing like hologram thing. And then
I didn't actually see that, but the fact of the matter is, you know, most companies do have a few pure programmers locked away somewhere in a dungeon, but they don't need that many of them because they are super productive. What they then need are teams of people to do the documentation, the testing, the integration, the presentation, the pre-sales, the post-sales, helping make it work when it goes out there to the customer. So, you know, in the industry, it's like massive industry. When people say to me, they say, "Oh, what do you?" I say, "I'm in computing." They say, "Oh, Joe's in computing. You must know him." I go, "Yeah." It's like saying I live on, you know, Earth and he's another Earthian. It doesn't quite work. The computer industry is just so vast. You know, and I thought I was going to be a programmer, and then after a while I thought, Jesus, this is really deadly dull. You know, it's all to do with debugging my code. Why did I put so many bugs in it to start with, you know? I mean, can't be helped. But it took forever to get them out. And I do actually remember that I was very proud of something, and I worked on it so hard that I deserved a holiday. So I went off to South America for 4 weeks holiday because I was so happy with it. 50,000 lines of code. This thing could compute answers within about 3 seconds. And that was amazing, because before it took months. I was delighted. When I came back, this other guy, Phil, who was one of these geniuses people, had gone through my code, found a few things with it. He'd rewritten it in the 4 weeks I was away. It was now not 50,000 lines, it was only 10,000 lines. And the 3 second had come down to less than a tenth of a second. Yeah, so that's when I thought, you know what, maybe programming isn't for me. But he was one of those exceptional programmers who had the ability to manage multiple variables in his head simultaneously, and think in multiple dimensions at the same time.
Do you believe, like, see, with programming, is it more based off of memory than like actually? Well, obviously you're gonna have to actually know how to structure your code, right? But like, is it based off of like memorizing like how you actually write it out, like see with variables and functions and different?
Well, that's a lot. That's a big help, having a repeatable method for organising the labelling and the positioning of all the different artifacts. That's essential. But I think the big differentiator is, I always say, like, imagine you take everyone in this room, not getting personal, you put them in a warehouse and you say, there's 100 tins of baked beans at the end of the warehouse, go check them. You and me, let's say we're about the same, we'll go in, we'll count, 1, 2, 3, 4, 5, 6, 7. We'll get to about 90, 95, maybe, we go, yeah, they're there, yeah? Now, there could be 97, there could be 98, there could be 99 there, there could be 100. We probably would never know, because if we counted 99, are we going to bother counting it again? No, we can say, oh yeah, it's 100. The best programmers are meticulous. They would come back and they would be totally sure of the number. They would not get towards the end and go, oh yeah, that's fine. You know, they stick there and stick there and stick there, and they concentrate and they don't talk to you. They don't have these discussions. They just stick there and work through it and through it and through it until they have it working and documented and tested. And that takes a certain caliber of person, you know. And
does it take like motivation, you say, or like determination, or like drive?
Persistence, ambition, what you enjoy. I mean, some people, the best programmers I know, enjoy it. I don't know why. I just go like, why would you? You know, they sit there for hours and they get it working. You know, I go, oh, that'll do. They say, no, I haven't totally finished the system testing. I go, oh my God. Okay, fine, whatever. But you know, there's a lot of room out there, and you just got to work out where you fit, and you have qualifications. Obviously, if you have a first, it helps. 2-1 is okay, but you know, you really do want to try and get a good degree. The better you have, the better you look, and then learn, you know, 3:15. So I'm going to have to go in 7 minutes. So I don't think we really need to. I was going to talk about VisiRule, which is the thing I'm working on at the moment, which is a no-code, low-code visual thing. That's all right. Don't worry about it. And it's used by all these people in different domains to do different things, and that's some screens from it, and it's basically visually capturing the rules that the expert might use to solve a problem, and then it spits out rules, it spits out tables, it spits out questionnaires, users fill them in, and then it generates documents, advice, guidance and analytics. It's very interesting, and if anyone wanted to use it at any point in time, I'd be happy to get them a copy and they could play around with it. At one time this was taught at LSBU, some of the rule execution stuff, the prologue stuff, but I think that was a long time ago. But this stuff is around. It's not flavour of the month yet, but we live in hope more than expectation. And so at LPA we have the VisiRule, we have the Flex Expert System, we have the Prologue engine, and under that we have C#, .NET, Java, Python, blah, blah, blah. So we have these layers of different kind of things for modelling different kind of things. So, we use a lot of REST, and we do text processing, and we have these different ways of building representational models. So there's some interesting technology there, and then we have some pictures of what people draw, and there's maybe bits of code splattered in there. So it's low code, no code. I mean, that is really weird because it's like written back to front. So I don't know what happened there.
What is it, like Node Red?
I don't know what happened. No, it's my eyesight probably.
Is it like Node Red? Is it a low code, no red?
Low code, low code, no code, no cliff. So I'm told, whatever that means.
Is it a bit like Node Red then? Where you can write your variables?
I have no idea. I had a quick look last night. 142 things that are all in this space, all saying they're unique. So go figure. It's another one. Yeah, and it's kind of helps break things up a bit, and it's just that visually you can see a bit more of the flow of the logic than in the old text-based representations. It's using D3, which is one of these JavaScript things to do radial visualization. There's a load of stuff out there, and then some automated testing stuff. I don't know what that's doing in there. Yeah, so this is some German thing. So the testing can generate randomized data and then run it thousands of times and collate all the answers and tell you things. So, yeah, VisiRule. One day I might come back and talk to you about VisiRule, but that's for another day. So look, hopefully this has been an interesting session. You and I have enjoyed ourselves, haven't we?
I'm so
sorry,
man.
You're not shy, are you?
I'm sorry. I think
maybe you should come to my next talk.
Yeah,
I could use a guy like you.
Tell me where it is. Send me the Eventbrite link.
I'm joking.
Oh, sorry.
I don't do this very often. Normally I talk about the software, and then I don't want interruptions.
Okay. I know. I didn't really want to talk. It was bouncing conversations, so yeah, man.
Thank you so much for
Okay, thank you. I want to make sure I don't take your phone. No, I think that's your one.
That's mine.
Oh, spot. See, I could have gone off with your phone there.
Let me put the recording.